So I've got to talk. So yeah. Now I did do a presentation on this quite a few years back on something called the Orbs game, and it was rather unimaginative because literally they were little balls that I made. So this is one of the ones that was rescued from before. This is just a craft ball that's about, I think, 10 centimeters in diameter, and I just sprayed it with the frosting to put a little board inside. And inside here you have a little PCB that I made, which is circular, has an ESP8266 module just there to do Wi-Fi comms, has a PIC chip microprocessor to do sort of very low powered stuff, some flashy LEDs, and underneath there's a connector. It's missing at the moment because I'm using it elsewhere, but an RFID reader, an MFRC 522. It's a very common one you can get very cheaply from China these days, knockoff processors in it. You can get the whole reader for under £1. So that was the original one. The idea is that you have lots of these dotted around. So I made a whole load of these and dotted them around a festival, EMF camp. And what you would do is you would go up to it, you would grab an RFID card, place it underneath, and it would read the RFID card. And then it would turn on the Wi-Fi, talk back to the game server that would then say, this card belongs to this team, or this is a card I don't recognize. And it would then allow the user, if it wasn't recognized, to pick a team. So it would cycle through the different teams. And when it went to the team that they wanted to be on, they could beep the card again, and it would make a little beep, and then it would start turning to that color. And the idea was that people would go around, and wherever they saw these, they'd beep their card, and then it would start flashing their team color. So that was what I did for 2018, and it worked, but there were quite a few issues. So as you can see, there's nothing really holding this together. So they didn't really stay as one piece very reliably. It also meant that if I wanted to open it, I had to break any kind of seals that I'd put on it, which then made it harder to put it back together again. As a power source, it used a lithium-ion battery, but it had no protection circuitry on that battery. So in theory, it could drain the battery, completely screw it, and then the next time you charge it, it explodes. So there's a little bit of worry there. And I also found quite a few other little issues, like, for example, the quality of connectors. So you can see that little connector there. It's just a sort of a normal pin header type thing. Those are not all created equal. And I had a lot of them that had intermittent or poor connectivity on certain pins that caused various problems. Like, for example, leaving the RFID reader powered up all the time. And of course, when you've got an RFID reader powered up all the time, it uses a lot of power. So there was various problems with the units not powering themselves down properly, and therefore running out of battery way quicker than I'd anticipated. But everything I did was about make it low power. So I thought, well, it's been 4 years. I should probably make an update game that's a little bit more interesting. So I thought, you know what, I'm going to create a slightly different look. What I'll do is I shall share my screen because it's easier to show. So if I can figure out how to do it, because my option doesn't appear to be there under share screen. Yeah, there we go. Right. Screen to share. There we go. Right. So we have, hopefully you can all see that. I'm just going to get rid of that off the screen. So this is the case that I created. And the idea is it's this disk here is the main case. And then this is the back that clicks onto it. And inside here, you have a clear Perspex disk that is inserted to kind of, so people can see inside it. So it looks a little bit cooler. And if I just spin around a little bit, there's a little bit of a mounting just there into which I can install some LEDs to shine into the side of the Perspex, so I can illuminate the Perspex. And these bits here are to mount the antenna. So the antenna is held in place inside the case. And around the edge, these little kind of dips are to hold a NeoPixel strip. The PCB is mounted on these things. So you can see the little standoffs there. So they hold the main PCB. And that's kind of most of the components. Oh, on this side, there's a speaker. So the previous one used these tiny little speakers that were about 2 centimeters in diameter, which were fine for making beeps, but they weren't particularly loud. And they also, it wasn't really practical to do much more than make them beep. And that there is a little outlet for a charge socket. So this bit, zoomed out too much. This bit, it's being really laggy. There we go. Right. So that bit just there, that holds a little charger module that allows me to connect a USB-C cable into to charge it. So, and then because I learned this lesson early on, so this is one of my many lessons learned, was that if you're going to have 2 bits that connect together, don't make it so that the bit that connects into the other one is easily breakable. Because one of the problems I had was, you spend 6 hours printing a part, and then you manage to break off one tiny little lug, and you've now got a useless part. So what I've done is, if you can see on here, again, it's just lagging too much. Right, just over here, you've got a pillar with a circular hole, and there's identical on the underside of this. They have exactly the same, a pillar with a circular hole, which means I can then use this little lug here. No, there we go. This little lug here to join the two. So I can print lots of these very quickly. And if they snap, and I just print a new one, and it doesn't really matter. One of the other reasons is when you're 3D printing, you print horizontally, is where your strength lies in that horizontal layer. Not so gaps between layers is where you tend to get a snap. So if I was printing this with the lug sticking out, then its weak point is the horizontal bit. So it's far more likely to snap off. Whereas I can print these laying down, so they have strength lengthways. So it allows me to with reasonable confidence, open and close it. And if I break it, I don't have to spend sort of a day reprinting the case. So that's kind of the case element to this. I'm also printing this in clear plastic. So the idea behind this is that it makes it very easy to visualize stuff. Just going to grab. The assembled case. Let me just stop showing this for a moment. So that is one of the cases that has been printed and assembled.
Can you hold your hand against that to give a size?
Can't hear you, Ben.
Can you hold your hand against that to give a size scale?
No, still can't hear you. I think you.
Yep, doesn't matter.
We can hear you, Ben.
So that's
a lot bigger than the ball.
And printed product. Now, what I do have is this is kind of it in pieces, so you can see inside with some bits. This one isn't turned on properly at the moment. In line with the comments about errors in PCBs made earlier, I made mistakes on this one. So this is a prototype PCB, and there's a whole load of errors on it. One of the errors is that I forgot to pull down the MOSFETs that drive the power to the NeoPixels. So the idea is the NeoPixels can be turned off totally, so they don't draw any power when they're not running. The problem that created was, if you don't pull a pull-down resistor and you power off the chip that's driving the pin, then it starts floating all over the place and lets power through. So one of my many little bugs. Now on this PCB, if you can see, you've got battery, there's a little DFR 0299 module. So that has a micro SD card, a built-in audio amplifier, and has a serial interface. So what you can do is you can talk at 9600 BPS over a serial interface and send little commands to play different files that are located on your micro SD card. And these are available if you buy them from a normal retailer for about sort of £9, I think you can get them from Rapid. I bought 40 of them for £29 from China. So they cost me less than £1 each. The micro SD cards cost more than the actual audio module. The other things you can see here really are just connections to the NeoPixels and the speaker and some buttons. One's a reset button, one's a power on button. The interesting stuff, of course, is on the other side. I'm just going to flip the board over. So on this side, we have the RFID reader card in the middle. We have a little PIC chip that does a lot of the low-powered processing. We have a Wi-Fi module. This time I've used the ESP8285, rather than the 8266. The reason behind that is because the 8266, I had a lot of problems with the quality of those. I had them not flash properly. I had them just randomly corrupt themselves. I had so many problems. Whereas these ones, they're smaller, which wasn't actually a factor in this. But most importantly, the EEPROM is built onto the expressive chip, which means that it's decent quality. So hopefully a bit more reliable. And the other thing is up the top here, and that's just a 3.3 volt regulator that can provide power to the board. And that has an enable wire run to the PIC chip. So what happens is when you press the button to turn it on, it sends an enable voltage through to the power module, and then the PIC chip boots and it provides the voltage on that pin to keep the module alive. And if it then detects a low battery, it will just say low battery and turn itself off. So the PIC chip knows that it's got a low battery. The way I've done that is there's a whole bunch of resistors that you can see kind of by the PIC chip. So 2 of those form a voltage divider, which allows me to then use an analog read of that particular connection. So it's got a sort of a resistor between the pin and ground, and a resistor between the pin and the battery plus voltage. And between the 2 of them, I can then work out what the battery voltage is at any point in time, because the PIC chip has its own internal voltage reference. So what it can do is it can generate a 2-volt voltage reference, and I then use that as the comparator for the analog voltage that I see. Can't use 3.3 volts as the comparator, because the actual battery could drop below 3.3, and then all I see is 3.3 volts, because the value won't change from there. So that's the reason why you have to use a different internal reference that's lower. So that's the main board. Oh, and that's the little I'd say that there is the little board that does the charging of the battery. The other thing is that this board here, you can see there's 4 slots for batteries. So if I want to, I could conceivably put 4 lithium-ion cells in this to make it run for as long as I possibly can. So I'm going to do some testing and see how many I really need for these to make them run for a weekend. So I'm hoping that I get away with 2, but I might need a few more. So the main architecture of this is a PIC chip which runs the low voltage stuff. So what this does is it's a very low voltage processor, so low powered processor, runs at 32 megahertz, and it will go to sleep, low powered mode, wake up 2 seconds later, check if there's an RFID card presented, and if there isn't, it goes back to sleep. And if there is one presented, then it wakes up the Wi-Fi module to go and validate that token with the game server. And it does that over MQTT. So if anybody's heard of that, it's a very simple messaging solution. So you have an MQTT server, and it's almost like a file path to the message location. And all we do is we just send a message. In this case, it sends it as a JSON message, just saying, I've got this card. Can you tell me which team it belongs to, or if it's unknown? And the game server looks it up and responds back via MQTT, which the unit then listens to, it looks at, and then responds appropriately. So the game mechanism is exactly the same. You pick a team. Once you pick the team, every time you present the card, you capture it for your team. And if it's already on your team, then it just registers that you visited, and it's just a game stat at that point. And the Wi-Fi module is using MicroPython. And so all that does is when it wakes up, it waits for a command from the, it tries to join Wi-Fi, tries to get a connection to the MQTT server, and then depending on what happens, it reports back to the PIC chip what's happened, and the PIC chip will then give it commands for it to go and do stuff. And it will then go and communicate whatever's been sent to it by the PIC chip to the game server and vice versa. So the actual game server itself is written in Python. So, and that runs on a Raspberry Pi, and it uses Maria DB, which is MySQL under a different name. So I'm just going to show a so this is the sort of code that I'm talking about for the PIC chip. It has different ports that run different things, so it can talk to the different parts and knows which pin, physical pin, and so on, that part is connected to on the PIC chip. And it has all the stuff to talk to the RFID reader in there, and how to talk to the NeoPixels. So there is, this is the game server itself. So this is all written in Python. So what happens is you have a game controller that connects to the MQTT server and listens for messages, and then responds to them. So, for example, it will send a message to the disk. Is this routine here? What we do is we authenticate every message sent and received. So I do a SHA-256 hash on the message and a private key that they both know. So that way the server and the disk will both know that they're sending messages to each other. And as I said, it's all stored inside inside a MariaDB. So there's a lot of stuff here about updating different attributes of the disks and players, and recording the disk visit and so on. It's all within this game server. And the game server, the database, it's all located on a Raspberry Pi. It's not particularly high powered. There is a separate scoreboard, but I have not touched that yet since the Orbs game. But largely it will work exactly the same, and I'll probably cover that another time. But the main mechanism here is that it sits there listening for MQTT messages, and when it receives one, it goes and does something. So it's very reactive as opposed to proactive. It waits for one of the disks to report in, and then it sends a message back to the orb or the disk. So yeah, that's kind of the main architecture of this. What I'm going to do is, well, I'm going to assemble this little board so that you can see it in action. Just take me a moment to do so, because frustratingly, I've managed to pull some of the LEDs out. So it'll just take me a moment to get them back in place. Well, Um, this is the one drawback with showing you the insides. One of the other things that I've been doing, I'm just going to stop sharing for a moment. The discs look like this, that sit in the front. So this is CNC engraved. So I got a very cheap CNC machine off of eBay, and they're pretty decent. The only thing is the bed isn't level, so I've got to figure out how to make the bed level. But it does a pretty decent job of engraving this acrylic. A couple of things I have discovered though along the way is that if you're going to engrave your acrylic, you need to make sure you engrave cast acrylic, not extruded acrylic, because cast acrylic is great for sort of physical etching, and extruded is better for laser etching. If you, in some of my earlier attempts when I used a bit of extruded acrylic, the acrylic actually kind of wound itself around the bit of the CNC machine and made a giant lump instead of an actual instead of engraving properly, and it ended up with a complete kind of mess of just nothingness all over the place, because it was effectively etching about sort of a centimetre wide piece of the acrylic by the end of that. So yeah, make sure you use the right type if you're going to go down that route. Right. So I have almost assembled this. And there's lots of lessons learned I'm going through with this at the moment as to how you design these things.
Have you put one together before? I didn't see a way of pulling it apart.
So in the back of this, what you saw, those buttons, there's a pillar in the case that actually connects with the button. So if I click on there, it will turn it on. It'll take it a moment. Disk online. So there we go. So that's now online. And what it will be doing is it will just give it a second. It should just start flashing white. There we go. So this is now an uncaptured disk. It doesn't belong to any particular team. I'm going to present a card to it.
Checking card. Crypto miner capture in progress. Crypto miner capture completed.
So there we go. That's that's been captured by one of the teams, and then you can present another card to it.
Checking card.
It should be a Cyan team, I think.
Crypto miner capture in progress. Crypto miner capture completed.
And if you want to, you can use a credit card. It does read them.
Checking card. New Polycoin user. Which team would you like to join? Magenta. Team Alpha.
This is it cycling through.
Yellow. Team Omega.
So you can pick which team you want to join.
Cyan. Polybius Biotech. Emerald. The chain.
So if I present the card again.
Registering. User registered successfully. Crypto miner capture in progress. Crypto miner capture completed.
So there we go. That's the total set of cycles that these go through. Yeah, so that's guess that's kind of most of it. While I think of it, one of the things I did was I used rather than having headers mounted on the PCB, I decided not to go down that route because I have to solder the headers onto every single one. I've got just PCB pads that are just bare and available. And then I made a separate PCB that's got little pogo pins. So you can just press the pogo pins against the PCB, and this little 3D printed case has 2 locator lugs on it. So you can get the orientation is always correct. So that way you can just push it onto the PCB, and these connectors here, that's to program the PIC, and that's to program the Wi-Fi module. So it allows you to do both of them on the board in circuit programming, but you literally just press and hold this onto the PCB, and then it all programs. So there we go. Right, I'll have a look at some of these this chat. Trying to work out where Ben's one ends. There we go. So the RFID cards are literally any sort of the what are they, 1.4, 14 megahertz ones. It's the ones used by lots of different things. So you can get these MyFair cards, and it will work quite happily with them. And those ones are really cheap from China, sort of 15p each. Or it can work with a credit card, or it can work with ultralights. All it does is it uses the identifier from the card. So what it will do is it will send a query, what's your identifier, and the card responds back with its number. And that number can be 4 digits, 7 digits. It's in blocks of 3 after 4. So it's always 4, 7, 10, 13. However long they are. All the ones I've read have been either 4 or 7, and I support up to 10. I think technically it can go up to 32. I'm not sure, but anyway, it nothing out there has anything longer than 7 that I've found. And yeah, they can be most types of cards. So how the game is played, it is very much a try and locate where they are. So the first kind of phase of the game is very much go find where they're hidden around the venue. So they will be there flashing white and uncaptured. And the idea is that on the game map, it will show nothing as to where they are. So people have to physically go out there and locate them to actually capture them. Once the first person's captured them, they appear on the game map. So providing I've got a game map of the venue correct, then it will show exactly where that disc is located. So everyone then knows where it is. And then there's 4 teams. I'm not sure if they exactly will stay, but I set 4 up for now. They will do just fine. Yeah, you effectively you join one team, and that card is then locked to that team, and you can go around and capture any of the discs. If it's already captured for your team, then you can go up to it and register that you visited it, and it just counts as a game stat to you that you visited X number of times or that number of discs. So yeah, the idea is that when you capture it, the disc will change to your team color. So as you can see, this one is currently flashing green because we captured that. We picked the green team and now it's flashing green. There's different animations, if you saw. So you've got a little kind of shaky effect, then a spinny effect, and a spin back the other way effect, then just a flash. And each time what it does is it actually turns the NeoPixel strip on using a MOSFET, and then sends the LED data through. And then when it's finished, it turns off the MOSFET. So that way the NeoPixel strip is not drawing any power when it's not actually turned on, because the NeoPixels have about a milliamp current draw when they're idle. So effectively, when you've got 7 NeoPixels sat there doing nothing, that's 17 milliamps of power that you're throwing away. So I didn't want that. And the actual way the game calculates is it has the number of seconds that you own a disc for is how long is how many points you score for your team. So if you've got if you go to 5 different discs and you hold them all for a minute, then you'll have 5 times 60 seconds of points gained for your team. I am looking at certain discs being more valuable than others, and some other game mechanics like certain discs only being held for a certain duration, or so there might be a maximum time you can hold one for. There's a lot of game mechanics I can play around with, but my focus for now has just been making the basic game work, and then I'll add those things afterwards if I've got enough enough time to actually code it all. Right. So how does Maria differ from MySQL? Well, MySQL is owned by a big corporate, and MariaDB is effectively the original developers of MySQL open source that decided that they did not like the direction they were going in, so they forked it and have gone in their own direction. So from a sort of a person that's not delved too deeply into it, MariaDB seems identical to MySQL in every respect I've dealt with it. All the tools that I've ever used for MySQL have worked with it. Interfaces seem to work with it. I'm sure there are differences from when they forked it, but for all intents and purposes, it's MySQL. Was I tempted by ESP32 boards with battery holder? It had to be a custom board because of everything I was doing. So I had to go and make my own one. So reusing somebody else's board had no interest. There was 2 elements to this. One was, can I do low power? And the ESP32 can do low power, but that processor is incredibly limited in what it can do. I want to be able to do an awful lot from a low-powered CPU. So when you consider what the low-powered CPU is doing, it's got it can communicate over SPI. It can, because it has to wake up every second or two to query the RFID card, which it does over SPI. It has to go. It runs the LEDs. It drives the audio module. There's all sorts of things it can do without the Wi-Fi module being turned on. So actually what it does is it tries to do stuff and then turn the Wi-Fi module off straight away, because that draws quite a bit of juice. And you just can't do that in the low powered core of the ESP32. It's just too small to actually achieve a lot of that stuff. So I didn't want to go down that route. The other reason is also one of time, because I've already got a lot of the code written from the disk, from the Orbs version. So when I made the disk version, it made a lot of sense to kind of port that over. I have rewritten an awful lot because I've changed a lot of the architecture, but at the same time, a lot of key bits, like for example, the module that would read the RFID card was literally lift and shift. So I didn't need to even think about recoding that. Is it like a laser tag venue? No, it's not going into a laser tag venue. This is actually going to EMF camp and hopefully MCH as well. May contain hackers over in the Netherlands. Okay, so how do I open the case? So the way this is set up is there's standoffs behind the PCB on the back case. So when you push from the front, the back begins to pop out open. So you can just about pop it open there, get your finger in and then pull. So it's quite possible to open that way. So there you go. So crack that open and then you just pull it apart like that. It opens fairly easily, but this is one of the reasons why I did that thing with the lugs. So if I snap the lugs, I don't have to worry. I'm just going to go with a bag of spares when I take it places. One of the things I have added that I haven't mentioned is there is a tamper switch. So if somebody does do this, the tamper switch will be triggered, and at that point, if it's regarded itself as online, it's going to flash blue and red and start screaming at you very loudly. So somebody's tampered with it. So the RFID reader is it's this little thing here, and these are ones that you can get off of lots and lots of different places. Oh, you can get these off lots of different places, but I got this off AliExpress, and they were something like 80p each. They're knockoffs, so the little chip on there is not made by NXP. It's a part they no longer make, but there's tons and tons of Chinese clones. When you read the version of the chip, you get a number that is entirely different to anything NXP ever released. So you know it's a clone, but it works. How do I program the PIC, VS Code PIC kit? Yeah, so what I use is something called Proton PIC Basic. It's a paid for compiler, but it's not expensive. It's something like 40 quid. It's pretty cheap. And all that does, I use VS Code as the development environment, and it calls the compiler, which converts it into assembler, assembles it, and then I use the PIC Kit 3, which is, again, one of these things. It's a very cheap Chinese knockoff of the PIC Kit 3. I don't think Microchip make them anymore, but they're really, really helpful, because what you can do is, I'll just share this for you so you can see. So this is the PIC Kit 3 Plus programmer. This, again, you have to pay about 15 quid for the bit of software. But what it will do is you can get it to provide power. I've unplugged it, so it's not going to work. But if I tick the on button, it will actually provide 3-volt power, or whatever I've picked in this little setting here. It will provide that power to the PCB. So you can actually power the PCB off the PIC kit. And you can also toggle the MCLR pin. So what that means is that you can put the PIC into reset and then take it out of reset. So you can effectively reboot your PIC on demand from this as well. And you can turn it on and off, because you can tick and untick that on button. And that allows you to, so you can program it and then immediately let this power the board. So when I was doing some experimentation with the RFID reader, that's one of the things that I did, was actually read the RFID cards. When I was playing around with it, I'd program the chip and still have RS-232 comms via a different method. I was on the. Let me just get this. So that is. I'm just going to stop sharing so you can see this. So that's the like a dev board when I was playing with the different components, and over here, there's a, I think it was, no, sorry, up this side, there's a connection to the RFID reader. So when I was testing it, this would actually be clipped on over here, something like that. And that would allow me to then test my code out when I was reading it. So what's the cost of all this? That's a very good question. I have no idea. When I did Gen 1 of the Orbs, the whole Orb came in at less than 10 quid. So that's including case, PCB, all the components, everything. But I learned a lot of things. I don't know if you can see on here, it's all through-hole components, very little surface mount. Whereas this new one is almost all surface mount and very little through-hole. And the reason behind that is time. It's very, very quick for me to build the boards in comparison, because you can just place all the components on there and just heat it, and there you go, job done. But I have learned a few lessons there as well. Some of the other stuff I did, I've played around with surface mount. And one of the big mistakes I did was putting surface mount on both sides of a PCB, because if you're professional and making these kind of boards, brilliant, you've got the right equipment. If you're a hobbyist, you don't have the same expensive ovens and so on that the big companies have, and precise timings, which meant that when I was soldering one side of the board, all my components were dropping off the other side because the solder was melting on the reverse side as I heated up. So I now put all of the air surface mount components on one side. So that was a really big thing I learned there. The PCBs themselves are coming in at, so my prototype runs, including shipping, I get 5 boards for £16. When I do a production run, I'm expecting the boards to come in at about £1.20 each, I think. So it's something like I think I have to get 50 boards done, because it's like it did drop down is 30 or 50 and I want some spares. So I want to make at least 30, but I also know that I could ball something up. So I kind of want some more. So I've got my prototypes arriving hopefully later this week, my version 1 boards. And if they're good, then they go off for a full production run. So did I do this all alone or have a team? I did this all alone, just me, and it's been, yes, quite an effort, learning a lot of different things. So learning a lot about 3D printing, learning a bit about CNC machines, learning about all sorts of things. And one of the things that I haven't shown you, which I've only just managed to do, and I haven't yet perfected, is I've got it now to read the payment information off a credit card. So it's not the full payment information. All it's doing is retrieving what's called the to-pay file, and the to-pay file contains a list of payment card processors that the card is has. So, for example, 031010 is a Visa card. So one of the little things that I'm working on that I have not yet got working is, if you were to give it a Visa card when you first register, it's going to go, I recognize that as a Visa card, and then it's going to say, I don't know if you'll be able to hear this.
Donation to Polycoin. Click Visa card accepted. Authorizing donation to Polycoin. Please wait. Just kidding.
So I don't know if you can hear that. But yeah, so it's going to be a little bit of a joke, but I know I can do it. So I just need to get the code working for that. Cool. All right. So any more questions? Feel free to speak.
When the acrylic wrapped itself around the bit, did you think to yourself, oh, yes, of course, or did you have to debug what on earth was going wrong? Hello?
I can hear you.
Okay, I can't hear anybody.
You hear me? Hello?
Oh, yep, I can hear you.
Good.
Have you got us all?
And me.
Cool. Excellent. So, yes, I just feel like I've spent ages talking, so somebody else talk.
Just a couple of minor things, Michael. Can you hear okay?
Yep, I can hear you fine.
When the acrylic wrapped itself around the bit, did you kick yourself, or did you actually have to debug that? And if so, where on earth do you start?
Well, I realised I'd already done a little bit of reading up, so I knew that was a problem.
Okay.
Knew that acrylic came in the two forms, and what I was using was extruded rather than cast. So interestingly, you can use different bits, so you have to be careful which bit you're using. It's effectively what I learned. You can get these ones that are almost like a very pointy tip, and that works okay with extruded, although the finish is not as nice as you get with cast.
And another piece of nitpicking, you have your external USB socket on the PCB, and you've got a USB sized hole in the cover.
Yep.
Did alignment work out fine, or was there any learning point in that?
Yes. So one thing I did make the mistake of is I tried to get it perfectly aligned the first time, realised I got it out by 1 millimetre. So I adjusted the design by 1 millimetre, reprinted it, realised that I'd moved it 1 millimetre in the opposite direction. So it's now 2 millimetres out. I had to correct. So you may see a stack of cases there. So that's the stack of shame. Ones that have gone wrong. There's 2 more over there, actually.
Yeah,
Sorry.
milling plastic can be a real pain. It tends to melt itself onto the bit instead of cutting it.
Yeah, so that's when you use extruded rather than cast. So all of the main case, so all of this is that's all 3D printed. None of those problems, but the cast discs they etch quite easily, but not the extruded ones. The extruded ones will work, but I have to use a particular bit for them. It takes about 5 times longer because it's cutting out a far smaller amount, so that's why it doesn't melt. So you're just removing such as a fine amount each time.
I don't know whether it's practical, but I believe if you do it underwater, it doesn't do it.
Interesting. I'm not entirely sure I'd feel comfortable immersing my 3D my CNC machine in water. There are ones that have these jets that do it, cooling the print, but mine definitely doesn't have that feature. I wouldn't feel comfortable with doing that. It's just not. It's a cheap 120 quid one off eBay. So.
Fascinating project, but to elaborate on the CNC machine, is it worthwhile getting and is it messy?
It's messy. I mean, obviously you get lots of shavings coming off it, but they're just little bits of plastic shavings, so it's pretty easy to clean. The actual end product you can just run under a tap and just get rid of any dirt that you've collected through the process.
Oh, so just a vacuum cleaner sorts all the swarf out.
Yeah, exactly. It's I ended up going through a little bit of a process trying to find the right tools for doing it. So I actually used Inkscape to create the design I wanted, and then exported that to a website that converts that into G-code, and then used a G-code sending application to send it to the CNC machine. Complicated. So it's not as smooth as the process with the 3D printer.
Thank you.
Excellent. Anybody want to talk about anything else?